Hello students, this is Dr. Faizan Mirza and I am discussing oxygen debt with you. What's oxygen debt? To understand the concept of oxygen debt, we need to understand what's oxygen deficit. So oxygen uptake, for example, is represented per in dmq per minute on y-axis, and this is the graph of how the oxygen uptake changes over time if a muscle is at rest or at exercise and during recovery. I have shaded these regions to outline what represents oxygen deficit and what's oxygen debt. Because once the person is at rest, the muscle was using less oxygen. During exercise, it used up more oxygen. During recovery, the oxygen level again goes back to the normal value. For example, this activity lasted these minutes as mentioned on the x-axis. For the first 2 minutes, the person was at rest. Then from the second minute till 6.5 minutes, the person was working out or performing this exercise, during which oxygen uptake increased. And beyond that, the person was resting for the next 25 minutes, a total of 25 minutes, not next 25 minutes. The baseline oxygen uptake in this case was about 0.2 dmq per minute. The demand increased as exercise began. This was the basal metabolic rate because the muscle was at rest initially. Uptake of oxygen increased to 2.5 dmq per minute. This value got increased from here. But this did not occur right away. It took about 2 minutes for the oxygen level to rise up to this value. And during this time, lactate pathway occurred meanwhile together with aerobic respiration to provide additional ATP molecules for exercise to continue because the demand for ATP use was more. This builds up oxygen deficit. So ATP is produced without all the oxygen being available. The exercise continues for another couple of minutes, but as lactate builds up, the person feels fatigued. The person cannot continue exercising for long. The person is breathing deeply and taking more oxygen than he or she was initially because he or she is now paying back for the oxygen deficit. This is oxygen debt. Oxygen debt ends up producing more of oxyhemoglobin. Lactate is converted to glycogen, and this increased metabolic state of organs after exercise is ended is maintained as well. So oxygen debt is actually how the body pays back for the oxygen deficit because it produced ATP without all the extra oxygen being available because the cardiovascular system was taking time to bring about the necessary vasodilation and increasing the blood pressure and the ventricular contractions, and in that time the person was still exercising. How the energy values of the respiratory substrate can be calculated? They can be calculated using a calorimeter. A calorimeter is having water here, and a unit mass of a substrate is burnt in the presence of oxygen. Initial temperature of water is noted, and once the unit mass of a substrate is burnt in oxygen, the final temperature of the water is noted again. Using Q is equal to mc delta T, the amount of energy liberated can be calculated. So amount of energy which is given off by respiratory substrate differs. We know that fats give out more energy as compared to others. So what are the energy density values? Energy density values of carbohydrates is 15.8 kilojoule per gram. Lipids is twice almost of that, 39.4, in fact more than twice, kilojoule per gram. Protein is only 17.0 kilojoule per gram, still higher than carbohydrates. So why exactly lipids have a way higher energy content or density as compared to carbohydrates? It's because of the hydrogens in the fatty acid tails. The hydrogens in the fatty acid tails can be fed into the Krebs cycle because fatty acid tails can be cut to 2 carbon units in the mitochondria because the mitochondria is having those enzymes that can cut the fatty acid tails to acetyls. And these acetyls can enter Krebs cycle directly without the involvement of glycolysis and link reaction. And we know that Krebs cycle's biggest contribution to aerobic respiration is the production of the reduced NADs and reduced FADs. The more reduced NAD and more reduced FAD are produced there, the more oxidative phosphorylation will occur and more ATPs will be produced from that. That's it from my side. Thank you so much.